Welcome to video 5.3 on predicting products for the 5 chemical reactions we've already learned. In this video, we're going to practice and see how we can use these 4 steps I'm going to give you to predict any product in a chemical reaction. In other words, I will give you the reactants, and then you have to do some thinking to come up with the products that will be formed. In this video, we're only going to look at the word diatomics. We've already covered a little bit, but I'm going to cover it again to make sure you get this in your notes and on your periodic table. But really, this video is more about practicing than there is a lot about content. So what's going on in this video? This video is really a combination of 3 things we've learned so far. The nomenclature and how to write chemical formulas of last unit, the reaction types, which you watched in last video, and then how to balance equations, which you watched 2 videos ago in 5.1. So as we get started, the whole goal of this video is for you to be able to see that I give you 2 reactants and you need to be able to predict the products. And so again, before we get started and looking at our steps, let's remind ourselves of what are the 5 different chemical reactions we've learned so far. So here on the slide, you can see that I have the 5 reactions we've learned, and they're generic chemical reaction. So we have synthesis, where 2 things are coming together, or I should say 2 or more things come together to form 1 compound. We have decomposition, where 1 substance is breaking down into 2 or more parts. We have a single displacement reaction, where 1 element replaces another element within a compound to form a new compound and a new element by itself. Remember, single displacement is like when a guy or a girl steals the boyfriend or girlfriend of another couple. Double displacement is when it's 2 compounds switch partners and create 2 new compounds. And again, this is like going on the double date disaster. And this will all help you as we think through this, and that's why I'm reminding you of this. But the double date disaster, where 2 couples go out on a date together and they leave home with each other's partner. And then the final reaction that we're looking at is the combustion reaction, where it's some kind of carbon-based fuel reacting with oxygen to produce carbon dioxide and water. And so this is something you really need to start committing to your memory because, again, in examples like this, it's going to show up. So as we get started, make sure you have your periodic table out, and also make sure you have the solubility sheet that I gave you in class. Likewise, this is a video where you need to practice the problems. I'm going to have 3 practice problems, so make sure you do have the video notes or at least a scrap piece of paper to where you can show me in class that you attempted these problems or at least walked through them with me. So as we get started, here are the 4 steps in order to predict our products of a chemical reaction. The step 1 we want to do is, based on the reactants, we want to start to try to identify the reaction type. Identify which of the 5 reactions we're trying to produce or write down. Step 2 is, let's go ahead and write out the simplest form of the products based on the reaction. And again, using this information, a little practice, this should be something that should be manageable, where you can write out, you can switch up partners, you can break down compounds, but you can start writing out products based upon what would be the simplest form of those chemicals. As we get started here, we're going to need to use our activity list that I gave you in class when we do single displacement reactions, and I'll show you an example of that here in a second. Step 3, correctly write out each of the chemical in your products. So, I'm sorry, correctly write out each of the chemical formulas, that should say formulas, in your products. Remember, you need to use your oxidation numbers, so you got to cross them to get the correct chemical formula. And again, that solubility sheet I gave you in class, we're going to use that to determine whether things are aqueous or soluble, or whether things are solid or precipitate. And then the last step we've already done is balance our chemical equation. So a lot of this we've already done. Right now, we're just looking on how to do step 2. How can we start to predict our products? So as we get started, let me remind you of what a diatomic is. A diatomic are 7 elements that do not exist by themselves in nature. Basically, when you're in nature, there's not just ever a single hydrogen, but there's going to be billions and billions of hydrogen atoms all around each other. whether it's just a small pocket of hydrogen gas or if it's a big pocket of hydrogen gas. There's going to be millions and millions of atoms of hydrogen together. Well, because of hydrogen's nature, along with these other diatomics, they will actually bond with themselves and never exist as an individual atom, but always exist as a hydrogen molecule, which is H2. And so that's the same for all of these guys. So whenever we write out our chemical equations, as you guys have been doing, whenever you come across the individual element of hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, we don't just write those down as individual elements, but we write them down as H2, N2, O2, F2, Cl2, Br2, I2. So a couple ways for you to remember this and to recognize this is they will form a 7 on your periodic table, and I'll show you what I mean here in a second. Or you can memorize the phrase Honk-Labrif. Honk-Labrif. And that, again, is your H-O-N-C-L-B-R-I-F. When you're looking at it on your periodic table, let me show you again what that means for them to form a 7. So if this is my periodic table, and if you want, you can go ahead and draw this 7 out. But if you basically highlight nitrogen, oxygen, fluorine, and you drop down to iodine, you can begin to see this forms a 7 on your periodic table. And so it's this plus that of hydrogen. So if you want to highlight him or bold him out, you can. But those are your 7 diatomics. So the best I got for you on the memorizing these is remember Honk-Labrif or draw a 7 around them to just remember. But again, as you use this, this should become pretty self-explanatory. So again, let's get started. Let me show you this first one. And then the next few you can practice. If you do feel confident and you want to try it yourself, go ahead and pause the video. But right now, watch how I do it, copy it down. All right, so we're going to predict the products of the following chemical reaction of silver chloride and aluminum. So what we want to do is we want to go ahead and write this out. We have AgCl plus aluminum. And what we're doing is we're predicting the product. So that means is we're drawing our arrow and we're trying to guess what will form here. So the first step I told you to do was to look at what was the type of chemical reaction. So as I look at this and I'm getting familiar with my reactions, I should look at here and I should say, okay, what type of chemical reaction is this undergoing? And so again, if I see here AgCl and I look at my list, go ahead and think about it. Can you identify what type of reaction this is going to undergo? Okay, pause the video if you need to, but the answer is a single displacement. So I see that one element is going to replace this compound. I got a compound and a single element, and so what's going to happen here is this is going to be a single displacement reaction where one element replaces the compound here. Now, in class, I gave you what's called an activity sheet. This activity sheet is kind of like a rating scale of who is super reactive and who is not reactive. Think about back to when I told you to memorize how a single displacement reaction occurs. It's like a couple is at a pizza joint and some studly guy walks in and he steals that guy's girl. Well, what is going to allow this guy to steal this guy's girl? Well, it's going to depend on his attractiveness, how reactive he is. Is he a 10 out of 10 or is he like a 2 out of 10? And so basically how we use this sheet here is we look and check between the two cations who is more reactive, who is higher up on this list gets to walk home with the girl. So we see here that silver, Ag, is very unreactive. So this is like basically saying he's like a 2 or a 1 on the 10-point hotness scale. Aluminum, however, is more like an 8 or a 9. So I will know and I will see that this reaction will happen because aluminum is like a 7 or an 8 and he's going to steal the 1 or 2's girlfriend at the pizza joint. And so we're going to allow aluminum to steal chloride, and therefore silver will be left out on his own to walk home by himself. Now, as we do this, we have to make sure we are writing our chemical equations correctly. Here, I gave you the chemical formulas correctly, but here you have to be able to write aluminum chloride. So what do we need to do? We need to check the oxidation numbers. Again, this is review. but we need to cross our numbers. And so we see this is a aluminum chloride. Oops, I messed that up. This is aluminum chloride, and then silver can exist by himself. One last thing that I want you to practice doing is, again, going through here and identifying the phases of these elements. And this is part of writing your chemical formulas out correctly. Aluminum, we know, is a solid. Silver chloride, you don't know. Same with aluminum chloride, but you should also know that silver is a solid. So now to be able to decide whether these are liquid, solids, gases, or aqueous, we're going to use what's called the solubility table that I gave you in class. So again, the word soluble means they will form or they will dissolve in water. So if something is soluble, they will dissolve or melt in water. And so what this does is it tells you what kind of compounds will melt or dissolve in water. So here we have aluminum chloride. So to decide whether it's aqueous or not, I have to find the chlorides, and I said they will all be soluble. They will all be aqueous unless it's with any of these elements. And since I see silver is on this list here, I'm going to write him as a solid. So silver chloride at normal temperatures, and since I didn't give you any information, understand it's at room temperature, will be a solid in water. Aluminum's a solid. And now over here, let's look at my aluminum chloride. Again, all will be soluble, all will be aqueous unless it has one of these three elements. Aluminum is not one of those three. So here we would write AQ as aqueous. And that's how you use this sheet and this sheet. We'll practice more in class. All right, so now as we move on, we're going to practice another problem. Go ahead and pause the video, try this yourself. And so your job now, again, is to start by writing out the chemical formulas and then try to see if you can identify what type of chemical reaction is going to occur. Okay, welcome back. If you had some troubles, let me get you started with the first few steps. So the first thing we want to do is we want to start to write this out. We have aluminum sulfate. So again, we want to make sure we can write this out correctly. So what I am doing is I'm just writing down the ions. So now I can correctly start my chemical equation. So again, I'm going to cross my numbers, and I'm going to see that Al2 SO4 is the correct way to write aluminum sulfate. And then potassium chloride is just KCl. So now that you got that far, take a second and try to tell me if you can identify this type of reaction. What kind of reaction is going to happen? So based on what we see here, which type of reaction do you think this is going to undergo? All right, as you look, we should start to see that we have a compound and a compound. The only type of reaction that involves two compounds are the double displacement and the combustion. But even then, this isn't really a compound, this is just a molecule. And so we can see here, this is going to be a double displacement reaction. This is like your double date disaster. Two couples go on a double date, but realize that they like each other's boyfriend or girlfriend better, and so they walk home as completely new couples. So what we're going to see here is the aluminum, who is positively charged, who's a cation, will be attracted to the negative charge chlorine over here. So we're going to write AlCl. But again, I have to pay attention to my oxidation numbers, and I have to write this correctly. So that 3 tells me I need 3 chlorines. And then we're going to see potassium be attracted to sulfate. And again, I need to pay attention to these numbers. That 2 tells me I'm going to need 2 potassiums to react with the sulfate. Now from here, now that we have every chemical formula written correctly, we have 2 jobs to do. First, let's go through and decide whether these are going to be aqueous or solids. So these are your solubility sheet. I'll show you how to do the first one again, and then you can try the next ones. So we have aluminum sulfate. So I need to find my sulfates on here. And so they're all going to be soluble. They will all be aqueous unless it has any of these elements listed. Aluminum is not one of those elements. So therefore, since it's soluble, we're going to call this aqueous. Go ahead and pause the video and try the last 3 by yourself. All right, welcome back. Potassium chloride, All are soluble. Potassium is not listed here, so therefore he would be aqueous. Aluminum chloride, all are aqueous, all are soluble, unless you see Al here, which we do not. And then finally, potassium sulfate, sulfates, all are soluble. I don't see potassium listed here, so all soluble means all would be aqueous. Then the last step is we need to go through and balance it. How do I balance it? All right, so we're going to pick any element we want. I'm going to start with the chlorine. I see 3 chlorines, so I'm going to put a 3 here. That gives me 3 potassiums. That gives me 2 potassiums. So as I do that, I got 3 potassiums, I got 2, so that's going to be an issue here. So what do I need to do? I need to triple this. So as I triple that, now that gives me 6 potassiums. I need to go back and change that. I got 6 chlorines, so I need to put a 2 here. Now I have 2 aluminums, 3 sulfates, and we're done. I think I forgot to balance this a problem. If you did not already, take a second to balance this out correctly. I'll show you how to do it. 3 chlorines, so I need a 3 here. 3 silvers, I need a 3 here. Sorry, I forgot that step on the previous practice problem. Okay, our last problem here, combustion of propane. So again, pause the video, see if you can get this started by writing out the reactants, and refer back to that slide about how do we set up a combustion reaction. Okay, so as we come back, we can look at that sheet of different type of reactions. We see a combustion reaction is some kind of carbon fuel reacting with oxygen to produce carbon dioxide and water. And so as we get going here, we should be able to start to write that out. C3H8. And then we're going to produce that with oxygen to form carbon dioxide and water. How did I do that so easily? Because I have combustion memorized, and this is something you guys should have in your mind, that we just add that fuel to oxygen, produce carbon dioxide and water. Now we can go to town. We know this is a gas. We know this is a gas. And we know this is a liquid or a gas. Either way, we're going to call it a gas because I know it's combustion. Either way, I'll be flexible with that. Methane here, or sorry, propane here. Again, I'd have to give you more information here if I really wanted to hold you accountable on a test. But a lot of you guys probably know propane is liquid when we deal with it in our grills outside. But either way, I'd give you more information on that. So now as we get started, all we got to do is balance it out. So again, when I go to balance this, just pick any element you think looks scary to you. There's not really a big deal to me. We'll just start with carbon. I got 3 here, so I'm going to put a 3 here. I got oxygen, but I want to leave my oxygen for last. So now let's do hydrogen, 8 hydrogen. So I need a 4 here. So it gives me 8 hydrogen, 3 carbon. Balance out my oxygen. 6 oxygen, 4 oxygen is 10. So I need a 5 here. So again, I hope you can see that these are all manageable. The key idea here is that you really need to be familiar with what we learned in the last video on different types of chemical reactions. So maybe keep this reference tool handy. Maybe write it down in your notes so that you can refer back to it until you have them all memorized. But again, long story short, follow those 4 steps, use your activity sheet, use your solubility table, and you should be able to easily write out any chemical formula or chemical equation and easily predict the products of any chemical reaction you come across in this class. Have a great day.